Hey Jade, let's check these out. First things first, we're going to factor this trinomial completely. This is definitely one of the dirtier ones because we have some term out here and neither of these terms are a perfect square. So remember, when we're looking at trinomials, always take a look at the first and last term. If they're perfect squares, you can take it down really easy because it's a perfect square trinomial. In this case, it's not. So what we have to do, we're basically going to guess and check. I'm going to factor out our first term here, 7a squared. 7 is a prime number, so there's really only two possibilities, 7 times 1, right? And a times a will give us 7a squared. I'm going to factor my last term over here, 2b squared, and that's going to be 2b times b. Now the order might be different, of course. It could be b times 2b, of course. But we're basically going to look for something that when we set it up, you know, we're going to get plus 9 in the middle, and it's going to multiply to give us a plus 2. Okay, so let's basically what we do, and there's just there's no right way around it. Let me get a thinner pen here. There's no right way to do it. We just got to try it. So let's go 7a and a. We'll blast that in. Oh, what happened there? There we go. 7a and a. And then we'll just go 2b and b, and we'll just try that. Plus 2b and then plus b. And then what we're going to have to do every time is FOIL it out. So 7a times a gives us 7a squared. That's going to give us 7ab plus 2b. So there's our 9-2b, and then we multiply out. So I actually just fluked that out and got it right. So there it is, factored. Now, if that wasn't the case, I would definitely play with switching the order of these. Like I would put an a in here and then a 7a, because that matters when we have a coefficient out here in the front. And I would also then start messing around with, you know, the order of the second one after that. So there it is. That's factored completely on that one there. I hope that helps, but always just try them and FOIL every time. Okay? This next one down here, factor the polynomial completely or state that it's prime. Basically, we just have a binomial, and we're going to pull out the GCF here. So if I look at both terms, there's no x over here. So I have a 5 and an 80. 5 goes into 80. So our GCF here is going to be 5. And I'll basically divide each term here by 5, right? So here it goes away. I get x to the 4th minus 80 divided by 5. No idea, but we'll do it out old school just because it's the morning. Get the brain warmed up, you know. 5 goes into 8 once. We'll subtract that off. We get a 3. We'll drop that. And we'll get a 16 there. Okay? So minus 16. I'll just erase all that. So at this point, we're almost done, but check this out. We have a difference of squares here because any even exponent, 2, 4, 6, 8 is a perfect square, and 16 is a perfect square. So what we can do, we can think about applying our difference of squares. Basically, we just take the square root of the first term and the second term. So I'm going to copy my 5 down. I'm going to make 2 sets of brackets. The square root of x to the 4th is x squared. Okay? Now how that works out, if I had x to the 4, I could write that down as x squared times x squared. And using the product rule that we learned back in Unit 1, I can keep that still under the square root symbol. Square root of that is x, square root of that is x times x is x squared. So effectively, when you take the square root of an even exponent, you cut it in half. Half of 4 is 2. Little shortcut. So that's where that's coming from. So we'll take the square root of that. We always make 1 a plus, 1 a minus, and then we'll take the square root of 16, which is 4. Okay? But check this out. This is okay, but again, this is another difference of squares. We have x squared minus 4. So we have to catch that too. So it's going to be 5 x squared plus 4. This is okay, not a difference, so that's fine. But again now, we'll make 2 brackets just for this guy here. Square root of x squared is x, x, 1 positive, 1 negative, square root of 4 is 2, and 2. So now, this is factored completely. So you can see the big trick there, buddy, is it's actually a difference of squares, and then a difference of squares again. And if you miss that on the test, you're toast because you're not factored completely. Okay? So always be on the lookout for those differences of squares. And also x squared minus 1 is a difference of squares too. Okay? 1 is a perfect square as well. So I hope that helps. Drop me a line if it doesn't. Have a great day.